All right, today we're tackling something huge, something that's been a massive headache for AI developers. It's this incredibly frustrating bug that's literally holding back the next generation of AI. We're talking about something called the AI training collapse. So here's the puzzle, right? Picture this. You're training one of these super advanced AI agents. You're watching it learn, getting smarter, more capable, like every single minute. It's looking amazing. And then, bam, out of nowhere, it all just falls apart. The performance completely nosedives, the whole system just breaks. So the big question is, why? And you can see it right here in the data. I mean, look at this. These lines climbing up, that's the AI getting better and better over time. But then, you see that? That sharp, just catastrophic drop? That is what researchers call training collapse. And let me be clear, this isn't some minor glitch. No, this is a fundamental instability, and it's stopping AI from tackling the really big, complex, real-world problems. Figuring this out, well, that's the key to unlocking the next level of AI.
Okay, so to really get to the bottom of this, we've got to be on the same page. What are we even talking about when we say AI agents? What are these things that keep breaking?
Yeah, these are definitely not your simple chatbots. We're talking about agentic AI, or just agents for short. Think of them as AI systems that are designed to be autonomous. I mean, they can plan things out, use different tools, and carry out really complex, multi-step tasks all by themselves. We're talking about AIs that can browse the web for you, totally master a complex game, or even help out with actual scientific research. The potential here it's just enormous. But, and this is a big but, here's the catch. Training these things has been like building a Jenga tower. You know, with every new block you add, every new piece of learning, the tower gets taller and way more impressive. But it also gets more and more unstable. And just like in a real game of Jenga, the whole thing can suddenly come crashing down for reasons that honestly, until now, have been a total mystery.
So, how do you solve a mystery like that? Well, a team of researchers at UCLA had a pretty brilliant idea. They decided to do what car companies do when they're trying to figure out a safety problem. They built a crash test facility. And this is it. It's called the ARLArena. Now, I know this diagram looks complicated, but don't worry about trying to understand every little piece. The main thing to get is that this isn't a physical building. It's a really sophisticated software environment, and its only job, its entire purpose, is to be an AI crash test facility. They built it to break AI agents over and over again so they could diagnose exactly what was going wrong, step by step, variable by variable. So inside this ARLArena, the researchers basically took the whole training process and broke it down into 4 key parts. You see things here like advantage design, which is basically how the AI figures out if it's doing a good job, and IS clipping, which we'll talk more about in a second. Just think of these as the engine, the brakes, and the steering of the AI's learning process. By testing each one separately, they could finally figure out which part was busted. Okay, so after all that meticulous work, all those crash tests, what did they find? Well, they found the culprit. It turns out the problem was hiding in this technique with a kind of complicated name, importance sampling clipping, or just IS clipping. But here's a really simple way to think about it. It's basically the guardrails for the AI's learning. Its whole job is to stop the AI from making these really extreme learning updates that would basically make it swerve right off the road. And it turns out there are 2 different ways to set up these guardrails. Over on the left, you have what's called tolerant clipping. Think of this like having really flimsy, weak guardrails. It lets the AI learn super aggressively, so you see these really fast gains right at the beginning. But that aggression, it eventually leads to instability and, you guessed it, a total collapse. Now on the right, you've got sequence level clipping. These are like strong, reliable guardrails. The learning is a bit slower at first, more gradual, but it's super consistent, totally stable, and most importantly, it doesn't crash. And look, the researchers' own findings say it perfectly. They're basically saying that, yeah, tolerant clipping gives you that really tempting, super fast start, but it's a one-way ticket to training collapse. Real, stable progress only comes from that more disciplined, sequence-level approach. So the big question is, why do the weak guardrails fail? And this chart actually shows us. Right before the crash, you see this sudden explosion of what are called negative advantage sequences. Okay, what does that mean in plain English? It means the AI basically starts obsessing over its mistakes. It tries to learn way too much from its failures all at once. And this massive overcorrection is what sends the entire system into a death spiral. But, finding the problem is only half the battle, right? So, armed with this incredible new knowledge, the researchers didn't just stop at diagnosing the issue. Nope, they went ahead and built the cure. And this graph, wow, this graph just shows their success perfectly. I mean, just look at that solid blue line way up at the top. See how it's just steadily climbing? No drama, no collapse. That's their new method, SAMPO. While all those other methods are zigzagging all over the place and eventually collapsing, SAMPO is just cruising along, hitting the highest performance with rock-solid stability. So yeah, they called it SAMPO. It's a bit of a mouthful. It stands for Stable Agentic Multi-Turn Policy Optimization. But really, you can just think of it as a whole new recipe for training AI, a recipe designed from the ground up specifically to stop that collapse they discovered. So what's in this magic recipe? Well, it's got 3 key ingredients. Number 1, it uses those strong guardrails we were just talking about. That's the sequence-level clipping. Number 2, it has a much smarter way of understanding rewards from its environment. And number 3, it's really clever about filtering its training data, so it only focuses on the most useful and informative examples. And the results? What happens when you put all that together? You get a massive 25.2% average performance boost over the previous best method. Now that is not just a tiny little tweak. That is a huge leap forward in what these agents can do. All right, so let's zoom out. What does all this actually mean for the future of AI? Why should we care so much about fixing this one single bug?
Because stable training, it's the bedrock. It's the foundation for everything else. By finally solving this collapse problem, we can now build AI agents that are way more reliable, way more powerful, and much more scalable. It really means we can start giving them longer, more complex problems to solve without constantly worrying that all that hard work, all that progress is just going to vanish into thin air.
Look, this breakthrough really does open up a whole new frontier. It's like taking the training wheels off for AI agent development. So the real question now isn't if these agents are going to get more powerful. We know they are. The question is, what incredible complex challenges are they going to master next?